Hello! Alright, so today's section is all about proving triangles are similar. So if you remember from yesterday, for two triangles to be similar, we know that all three of their angles, so whatever angle is corresponding to the other, will be congruent. And then the side lengths will be proportional. So if we have two angles that are congruent, so in example, or in this example right here, angle K and angle Y are congruent to each other, and then J and X are congruent to each other. We automatically know that the third angle has to also be the same. So all three of the angles are going to be the same. So anytime we know that two of the angles are congruent in the two triangles, we know that they have to be similar. And that is called the angle-angle similarity. So we're going to be using that in proofs and when it asks us to justify and so on. So some helpful things to remember when you're trying to prove triangles are similar. So always draw, and sometimes you might have to rotate or flip one of the triangles and it'll make it a little bit easier to see what's going on. So I find the corresponding parts and then write the values of the angles. So anyway, in example 1, determine whether the triangles are similar. If they are, write a similarity statement. So if I took this triangle CDE over here and I wanted to make it look exactly like this one, I could flip it over. So notice that the longest side is on the bottom here. So the longest side is going to be on the bottom. 90-degree angles on the bottom left. So D was the 90-degree angle. DE is the short side. So this should be E. And then DC is the long side. So this should be C. So now it's really easy to see which sides are corresponding, which angles are corresponding. So H is 64. So E should also be 64. C was 26, so C should also be 26. So if you wanted to verify that that was correct, you could add up all three of these angles, so 64 plus 26 plus 90, and that would equal 180. So a triangle should always have 180 degrees when you add up all three of the angles. So I know that this angle is 64, this angle is 90, this angle is 64, this one's 90. So we know that the two triangles are congruent. So triangle EDC is similar to triangle. So since I wrote it in this order, I need to figure out which angle corresponds with E. So H and E are the corresponding, so I have to write H first. D is second, so D is the 90-degree angle. So G would have to be second, and then C is corresponding with K, so K. And the reason I can say that is because of angle-angle similarity. Because we know that H is congruent to E and G is congruent to D. So we know all three angles are congruent, but we only needed to find two. So in example 2, show that the triangles are similar, write a similarity statement. So similarity statement is just this thing up here. Right here. So whenever it asks for that, that's what it's looking for. So we know, based off this picture, that G, F, and H are all congruent angles. So what type of triangle? There's only one type of triangle that has all three congruent angles. So what type of triangle would that be? Hopefully you're saying to yourself or out loud, an equilateral triangle. So this triangle, FGH, is an equilateral triangle. If I look over here at R, notice, or RQS I should say, all three of these angles are the same. So again, if all angles are the same, then it's an equilateral triangle. An equilateral triangle always has 60-degree angles for all three of its angles. So we know that G and R have to be congruent. F and Q have to be congruent, excuse me. So we have two angles that are congruent. So I know that triangle FGH is going to be similar to triangle RQS because of angle-angle similarity. So angle R, I'll just write over here. Angle R is congruent to angle G. Angle F is congruent to angle Q. So really they're all congruent to each other, so I could really put any letters in there since they're both equilateral triangles. So this would be our answer. So in example 3, are the triangles similar? If so, write a similarity statement. So whenever we have overlapping triangles like this, I like to draw them separately because to me it's a little bit easier to see. So AEB, then we got ADC. So this is 52, this is 52. And then what do we notice about these two angles right here? So A and A are both going to be the same thing because they both share this angle right here. So A has to be congruent to itself. So now we know that these two angles are congruent. So A is congruent to A. And then since B and C are the same degrees, angle B has to be congruent to angle C. So we have two angles. So I can say triangle ABE is similar to triangle ACD because of the angle-angle similarity. So moving on to the next page. So we got a couple more similarity statements that we could use. So side, side, side similarity means that if all three sides are proportional or have the same scale factor, then we know they have to be similar. So even if we don't know any of the angles, if we know all three of the sides are proportional, then the two triangles are similar. If I know two of the sides are proportional and then the angle in between those two sides, so for example, if we knew that this angle and this angle were congruent, and then this side and this side and this side and this side were both proportional, then I could use the side angle side similarity theorem. So it kind of explains it right here. We'll go probably more in depth in class. You guys can read that, take a minute to read that. So example 4, explain how to show the indicated triangles are similar. So right away I can tell, obviously these two angles are congruent, so angle R and angle N are congruent because they're both 90 degrees. So let's take a look at those sides. So SR and PN are corresponding. So PN and SR should be proportional. PN is 18, SR is 24. So if I reduce that fraction, I know that 6 goes into both of these numbers. So 6 goes into 18 3 times, 6 goes into 24 4 times. If I look at RT and NQ, so I'm using those sides because they gave me the lengths of those two sides. So I use the smaller one on top first, I use PN, so I have to use the smaller one on top first here. So NQ is corresponding with TR, or RT. So NQ is 21, RT is 28. So I know 7 goes into both of these numbers. So 7 goes into 21 3 times. 7 goes into 28 4 times. So again, our scale factor is 3/4. So these two sides are each proportional with a scale factor of 3/4. And the angle that is touching both of those sides or in between both of those sides is also congruent. So I can say they are similar because of this side angle side similarity theorem. So example 5, explain how to show that the indicated triangles are similar. So again, I would like to redraw this. You don't have to, but I think it makes it a little bit easier. So this is Z, X, and W. So the bottom is the longest side. So when I draw the other triangle, the bottom should be the longest side. And the right angle is on the bottom right. So this would be Z. So now I'm drawing the smaller triangle over there. So the longest leg is ZX. So this should be X. The shortest leg is ZY. So this should be Y. And then the hypotenuse was XY. So XY. You could also kind of use these. So since X and Y are the first two sides, those have to be corresponding. Z and Z have to be corresponding to each other. And then W and X have to be corresponding. Okay, so now I'm going to write down all the lengths here. So this was 20, 16, and 12. So ZY is 9, XY is 15, and ZX is 12. So I know that these two angles have to be congruent because they're the same angle. So angle Z is congruent to angle Z. Then I can use the two sides that are touching angle Z. So let's use the smaller one first. So YZ, so this side has to be proportional to XZ. So YZ is 9, XZ is 12. 3 goes into both of those numbers. 3 goes into 9 3 times. 3 goes into 12 4 times. And then ZX and ZW are corresponding, so those would have to be proportional. So ZX over ZW would be 12 over 16. 4 goes into both of these numbers. 4 goes into 12 3 times. 4 goes into 16 4 times. So again, our scale factor is the same. It's 3/4 for each one, and then the angle in between those two is congruent, so side, angle, side, similarity is the reason why I can say that these two triangles are similar. So again, just a reminder, if you get overlapping triangles like this, a lot of times it's easier if you redraw them, because I have trouble just looking at those and seeing if they're similar.